Hello everyone, Jan to all. In this video lecture, I am going to discuss about the basic concepts of array. This subject is basically belongs to data structure, and this is the basic concepts of data structure. What is the data structure, how the array is created, and how the address of the given array is calculated. My outline is definition of array, types of array, calculating the length, calculating the address of any elements, representation of array, application of array. This is the basic terms in which we have discussed about the definition of array, types of array, calculating length. In calculating length, we have show how the numerically we have calculated the dimension of the array are row size, column size, or block size. Next one is calculating the address of array or any elements, in which we have to calculate the address of one-dimensional array, two-dimensional array, and three-dimensional array. The next topic is representation of array, how array is represented inside the memory, and the last topic is application of array. In the application of array, we show how this array is used in different types of programming language. Here we have discussed about the definition of array. The definition of array, as you know, the array is the collection of same type of data elements. That means if we define an array a type integer, then all the value of that array is integer type. If we declare character type array, then the value of all the elements is characters. Here we write array is the data structure containing number of data value, all of which are same type. That means if we declare like this, int arr, this is the name of array 10, and this is the length of array, this is also called the size of array. That means here we have allocate 10 contiguous memory location which start with 0. This is the default index of the array, 0, 1, 2, 3 up to 9, and this total 10 position 0 to 9 is store a integer type value. Integer type means like 2, 4, 6, 7 like this. There is no decimal value in the integer type array. We have only stored the integer value. The next point is data elements are stored at contiguous memory location. Contiguous means in the same pattern we have start with 0 and go on 9. That means if we declare a array of size 10, then the memory allocated of size 10 is a contiguous manner, one by one sequentially. That memory location is called contiguous memory location. Here we discuss the definition of data structure. What is mean by data structure? This is the format or organizing data. Data structure means data structure is the format for organizing and storing data. How the data stored inside the main memory is called data structure. In this case, we have also discussed how the operation is performed, which type of operation we have to apply on data structure. We also discuss in the data structure. Each data structure is designed to organize data to suit a specific purpose. That means if we want to insert or delete or traverse a data, then we have to use a specific data structure to perform such type of operation. Array is the data structure which you can visualize as we discussed in previous slide. The array is the collection of similar type of data element in which we have stored same types of data in the given memory location. Here we show how the data is created or how the array is created. This is the location which index is start with, default index is start with 0, 0, 1, 2, 3, 4, 5, 6, 7, and we store the value in this location here 2, 4, 3, 5 like this. This is the location in which we have to store the value of the array. Imagine an array is the large chunk of memory divided into a smaller block of memory and each block is capable of storing a data value of some type. That means this whole memory is divided into a small block of cell, and that cell contain the value which is declared according to the user. If we declare integer, the block is called contain integer value. If we declare float, the block is contain float value. Here some declaration of the array. We have declared int arr 10. This is a array which length is 10. This tells the length of the array or size of the array. This is the name of the array, and this is the data type, which type of value is stored in this array. Here we have shown how the value is stored. The index of the array start with 0, 1, 2, 3, 4 up to 5, 6, 7, 8 and 9. The size of the array is 10, so we have to start with 0 up to 9, and we store the integer value at the given places. Here int array 8, this is also the types of array, arr the name of the array, and here the size of array. In this array we have to store 8 value, that is 22, 55, 44, 88, 77, 99, 11 and 66. Index of this array is also start with 0, 1, 2, 3, 4, 5, 6 and 7. From 0 to 7 there are total 8 value in which we have to store 8 value because the size of the array is 8. Here we have to fix the length of the array. Now the next topic is types of array. This is the basic types of array in which the array is divided into mainly two parts. The first one is one dimensional array and second one is multi-dimensional array. In one dimensional array, the array is represented by one subscript. In case of multi-dimensional array, the array is divided into different parts. The multi-dimensional array divided into 2D, 3D, 4D and ND. That means array have two class. The first one is one dimensional and second one is multi-dimensional. Multi-dimensional also divided into different parts, 2D, 3D, 4D, etc. This is the types of array. And now what is mean by 1D array? What is the definition of 1D array? Yeah, what is the need of 1D array which is used to create a single dimensional array? A one dimensional array is a kind of linear array. This is also called a linear array. It involves single subscript. That means when we have to define int a or int b like this, int arr 10. This is the case of linear array because here we have to use only a single subscript to define the array, so that this array is called one dimensional array. In case of two dimensional array, we have to use two subscript like this, int arr 10 and second bracket is 20. This is called number of rows and this is called number of column. Here due to rows and column, this array is called two dimensional array. In 3D we have used three subscript which show later. This is the syntax of an array. This is the data type, which type of data we want to store in the given array. This is the name of the array, which is the user defined. We can use any type, any name in the place of name of array, arr, a, whatever you want to use, we can use here name according to the defined variable name. Here the number of elements, that is the length of the array. We can also use number of element according to our need, 10, 20, 30, 1100, which according to our need we have to define the length of the array. And the length of the array must be a positive integer. We can't use here negative number or a decimal number. The length is always a positive integer because as we know, the length of the array never be a negative or a float number. Here we have taken an example. An array of integer can be declared as like this, int arr 5. This is a array of size 5. That means the length of the array is 5 and the index start with 0 to 4. This is the name of the array arr and this is the index 0, 1, 2, 3 and 4. Here we have to store the value according to our need, which is given in the question. We have take as a programming point of view. Now the next point is how calculate the length of an array. That means if an array is given and we want to find how many number of element are, what is the length of the array, then we have to use this formula. Length of the array is upper bound minus lower bound plus 1. Here UB means upper bound, LB means lower bound. We have taken an example. Calculate the length of given array. The dimension of array is minus 10 colon 30. Here minus 10 is the lower bound of the array and 30 is the upper bound of the array. By using this value, we have to calculate the length of this array arr minus 10 colon 30. Here we have to use formula, same formula which is written here. Length equal to upper bound minus lower bound plus 1. The array is arr minus 10 colon 30. The LB is minus 10. The upper bound is 30. We have to put this value into the formula and we get answer. AV upper bound is 30, LB minus bracket minus 10. This is the value of lower bound. When bracket is open, minus minus converted into plus, 30 plus 10 equal to 40. This is the length of the given array. That means in this given array, we have to store 40 integer value in the assigned memory location. This formula is also used in next chapter, next topic. That means in case of calculating the address of one-dimensional array, calculating the address of two-dimensional array, or calculating the address of three-dimensional array. Now we are coming on to calculate the address of an element into the given array. Here we have considered one-dimensional array. Next we have considered 2D, then 3D. The formula for calculating the address of an array, and this is the advantage of an array. By using the formula, we have to calculate the address of any element into the given array. That means random access is possible in case of linear array. Here we have taken one-dimensional array. We want to find address of element at position I. The value of I, anything, and by using this formula, we have to calculate the address of element at location I. This is the name of array arr. Here a short form is BA, that is called base address, plus W into I minus LB. LB is the lower bound of the given array. I explain all the points. I is the subset of element whose address to be found. I is that element we want to calculate the address of location at I, and I is also called index value. Here BA is the base address from which location our address is created or our array is stored, that is called base address. W is the storage size, or we can say number of word per memory cell. What is the space or what is the memory taken by a single word in a memory, 2 byte, 3 byte, 4 byte, etc. LB is the lower bound, which is also discussed in previous slides. What is the lower bound of the given array, and UB is the upper bound, which is described the what is the upper bound of the given array. By using this formula, we have to calculate the address of given element into the given array. This is the main formula, base address plus W multiply I minus LB. Okay, in next slide, I am taken a example. The example is given the base address of an array A, here the given array, and the given array is one dimensional array because in this array only one subscript is given, and the base address of this array is 1020, and the size of each element is 2 byte in the memory. Find the address of A 1700. Look at the slides. Here the given array is A 1300 to 1900. That means the lower bound of the given array is 1300. The upper bound of the given array is 1900. And the value of W is 2. This is the value of 2. And the base address is 1020. This is the given data which is given in the question. We want to find the address of A 1700. That means we want to calculate the address of 1700, and 1700 is the value of I. By using formula of 1D, as we discussed in previous slide, and we also write here, in case of one dimensional array, the formula of address is AI equal to base address plus W multiply I minus lower bound of I. There are only one subscript, so we have to return lower bound or lower bound of I, as we discussed earlier. The value of base address is 1020. We written here 1020. The value of W is 2, and the value of I is 1700, and the value of lower bound is 1300. By solving this equation, we get 1020 plus 2 into 1700 minus 1300, we get 400. Multiply with 400 with 2, we get 800. 1020 plus 800 gives 1820. This is the address of element at location 1700. This is the formula to calculate the address of element in one dimensional array. By using this formula, we have to calculate the address of any element. If we want to calculate the address of element at location 1750, then what we can do? We can write a formula A 1750. That means address of A 1750 equal to base address plus W is same, W into multiply with 1750 minus LB, and the lower bound is 1300, which is given in the original matrix, this one. By putting this value, we have evaluated the address of 1750. This is the main formula which is calculate the address of element in one dimensional array. Now, the next question is also on the same. We have to calculate, suppose we want to calculate, this is the second array with dimension is A minus 10 dot 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 2 plus 2. Here the lower bound is minus 10, upper bound is 2, and the base address of this array is BA, that is 999, and the value of W is number of words per memory cell is 2. In this question, this data is given. By using the same formula, we have to calculate the address of the element at minus 1, A minus 1. We want to calculate the address of A minus 1. By using same formula, we have to calculate the address of A minus 1. Here, the A minus 1 equal to 999, that is the base address, plus W, that is 2, multiply minus 1, that is the value of I, minus 10, minus, this is the lower bound. After opening the bracket, this minus is converted into plus, minus 1 plus 10, that is 9, 2 multiplied with 9, 999 plus 18 gives 1070. This is the formula, yeah, this is the value which is show the address of the element at location -1. So we have calculated the any address of any location which is given in the array, and the address must be between the lower and upper bound. If the question is asking, then the address must be between the lower and upper bound. If we want to calculate the address of 4, then we can't calculate, because this 4 is not belongs to the given range of the array. The upper bound of the array is +2, so we can't calculate the value of A4. So this is must keep in mind, the value of address must be calculated in the given range. If the value is given out of the range, then we can't calculate the address of the given element. Now, calculating the address of element in the two-dimensional array. This is the formula which is used to calculate the address of two-dimensional array. Here we have to retain a matrix which is in the form of 2D, and the matrix is A, M, N. M is called rows and N is called column. Due to this matrix is called 2D array, because in this matrix we have to store in the form of row and column. This location is A00, this one is A01, etc. And by using this matrix, we have to calculate the address of array in the given format. Here we have used two methods to represent the 2D array. The first one is row measure order and second one is column measure order. This is the two method which is used to represent 2D array. In case of row measure order, first we have to represent row 1, then row 2, then row 3. In case of column measure order, we have to represent column 1, then column 2, then column 3. And we use two different formula to calculate the address of element in 2D array. The first formula is row measure order. In case of row measure order, we are using this formula. This formula is similar as 1D array. Here we want to find the address of ARRIJ. We have write here base address plus W into I minus LC. I is the row number and LC is the lower bound of rows. And here we are right here LR, not LC. LR is the lower bound of row number. Here J minus lower bound of column. We have to minus the lower bound of column with the lower bound of rows in row and the lower bound of column in column. I is the row and J is the column, so that we have to change here LR and LC. LR is the lower bound of row number and LC is the lower bound of column number. By using this formula, we have to calculate the address of any element in the given array. Here LR and here is LC. And now the next formula is column measure order. In case of column measure order, we have to write same formula, base address plus W into I is the row number, minus LR plus M into J minus LC. Here we have to multiply M and here we have to multiply N. In case of row measure order, we have to multiply row. In case of row measure order, we have to multiply in row by column value. This is the given original matrix in which M is the row and N is the column, and we are using row measure order. In row measure order, in row we have to multiply column. In column measure order, in column we have to multiply row. This is the reverse condition. In row measure order, row multiply with column, and in column measure order, column multiply with row. This is the main formula which is used to calculate the address of 2D array. Here I minus LR and here J minus LC. Now BA is the base address, W is the number of watts per memory cell, LC is the lower bound of column, and LR is the lower bound of rows. It is also discussed in previous slide. This is the basic things which is given in the question. Now I comes on our example. Here a question is given an array, the dimension of array is 1 to 10 and next one is 1 to 15 with the base value is 100 and the size of each element is 1 byte. Find the address of ARR 8, 6. We want to find the address of A86. The given value is base address is 100, the W is 1 and LB of row, lower bound of row is, that is called LR, is 1, lower bound of column is 1. This is the lower bound of row and this is the lower bound of column. The lower bound of row is 1 and lower bound of column is also 1. By using formula, here we have calculating by using formula row measure order. We are writing here I, J, B for base address, W into, this is the row measure order. We have to multiply row with column. The original matrix is ARR MN. So here we have to multiply with column because this is the row measure order formula. So in row we have to multiply the dimension of column, and the dimension of column, that means the value of MN and evaluated like this: M equal to upper bound minus lower bound plus 1. This is the upper bound for row, that is 10. This is the lower bound of row, that is 1 plus 1, and this gives 10. This is the value of M. By same way, we have to calculate the value of N, that is the number of column. N equal to upper bound minus lower bound plus 1. The upper bound of column is 15. We have put here 15 minus lower bound of column is 1. We have to put here 1 plus 1, and this gives 15. The value of M and M is 10 and the value of N is 15. We have put here value. The base address is 100. The value of W is 1. Bracket 15 into, this is the value of N which is calculated here. 8 minus 1, and this is the value of I. The lower bound of row is 1. So we have right here 8 minus 1. The value of J is 6. We have right here 6 minus 1. That is the lower bound of column is 1. By simplifying and solving this equation, we get address is 210. This is the formula which is used the row measure order. Now the next is column measure order, CMO. In CMO, we have used same method. In case of column measure order, in column we have to multiply with row number. In row measure order, we have to multiply column in row. In row measure order, we have to multiply here with N. But in row measure order, column measure order, we have to multiply M with J minus LC. The remaining value is same. We have to put here base address 100 as given in the question. 8 is the value of row. Here the lower bound of row is minus 1 plus the value of M is 10. 6 minus 1. The 6 is the value of J, that is here, and the 1 is the lower bound of the given array. By simplify this, we have get 157. This is the address of elements A86. By using this formula, we have to calculate the address of element at 86. And this is the method which is used to calculate the address of element in 2D array. Now, the next one is calculating the address of element in 3D array. In case of 3D array, we are using a formula, same formula, row measure order and column measure order, because except 2D and 3D, the array is represented by row measure order or column measure order. In case of row measure order, we are using same formula, base address plus W bracket M into N, P minus LP, that is the block size. P minus LP, LP is the lower bound of page number. Here, this is the row measure order. So, we have to multiply in row with column, and this is the lower bound of column J, C. This is the formula for column measure order. In this formula also page number is multiplied with row and column, and this is the lower bound of page number I minus LR, that is the lower bound of rows, and here LC, that is the lower bound of column. And by using this formula, we have to calculate the address of the given element. Here we have to multiply M into N in both cases. That may be row measure order, or that may be column measure order. But here we have used same formula as in two-dimensional array. In row measure order, row is multiplied with column. In column measure order, column is multiplied with row. This is the formula which is explain base address, W number of words per memory cell, LP lower bound of page number, LC lower bound of column, and LR lower bound of row number. This is a numerical in which we have to calculate the address of the given element, and the location we want to find the address is 5, -1 and 8. By using row measure order, we have to put the value of all the value, and we have to calculate the value. M is calculated like this: upper bound minus lower bound plus 1. This is the M, this is the P, and this is the N. M, N, and P. The P is calculated like this: 9 minus 1 plus 1, that is 9. M is upper bound 1 minus plus 1, that is 6. And N calculated like this: 10 minus 5 plus 1, that is 6. And now we have to put the value in the given formula, and we get this answer, 730. Same method is in column measure order. Column measure order, in same method we have to calculate the value of given array. Here LR and here is LC. We have to put the value of lower bound, and we calculate the value of the given array. This value also give 730. This is the basic operation: traversing, insertion, deletion, search, and update. Application of the array is like this: array used to implement data structure like stack and queue. Array are used to implement matrix and other mathematical implementation. Array are used to look up table in computers. Array can use to CPU scheduling. This is the main about the array. If any doubt, comment in comment box.